My name is Yoni Garberg. I'm with A Posteriori. I'm having a little bit of problem seeing everybody, so let me just adjust my glasses here. Oh, okay, there. I can see a lot better now. Welcome all. It's nice to have you today, this morning with us. I have with me Court. He's going to introduce us a little bit more formally, and we have a bunch of people from IMDA and AMC. And today we're going to be talking about automating your home with the Internet of Things. And we'll talk about what is home automation and what is the Internet of Things in a short while. But before we do that, I have a few housekeeping things to go over with you. For the duration of the time, I'd like to make sure you all stay muted unless you have a question. If you do have a question, feel free to interrupt as long as you think that question is relevant to what we're talking about and that other people might benefit from our answers. So feel free to interrupt us by unmuting and asking a question. If you're not talking, keep yourself on mute. IMDA and A Posteriori are recording this event, so please take note of that. If you don't want to be a YouTube sensation, you can keep yourself off video. But if you don't mind, please show us your face. We'd love to see who we're talking to and who we're interacting with. If you want to know more about our video recording and data privacy policies, please scan this QR code. And it's going away in 3, 2, 1. That's all we're going to talk about that. And I'm going to hand over the mic to my partner, Court, and he's going to get us through the first few slides.
Okay, morning everyone. Right, so for today, we are going to do home automation with IoT, that's Internet of Things. Next slide, please. Now, before we actually start on the presentation, we'd like to let you know that we do believe in open sharing of knowledge. So all our slides, we put it online for free. Everyone can take a look at it. You can print it, you can modify it, you can run your own programs with it. Okay, the link to the slides is at the bottom of every page. So if you miss it now, you can see it later. Next, please. Okay, a bit about us. Our company name is called A Posteriori, and it's made up of the two of us, Yoni and myself, Kot. Yoni spent about 15 years in the financial service industry. He's a very experienced programmer. And today he is training the next generation. Okay, he's training makers and coders. And for myself, I was an ex-Navy engineer. I used to manage ships, engines, generators, toilets, all kinds of stuff. Okay, I like to code and build stuff because I'm kind of a cheapskate. So I find it's a bit better for me to build stuff on my own. Okay, next one. Okay, our company is at Woodlands. We have our makerspace, which we do welcome the public to come in and use. We have people coming in all the time to work on their own projects. We also conduct some courses there. Next, please. We have a competition team which has been doing pretty well for themselves. They have been attending competition for the past 3 years, won an award every year. Okay, they come in on Sunday. We also do our holiday camps. We just completed one yesterday. In our holiday camps, we do all kinds of programs. The one that you see on screen right now, there's an underwater robotics program where the kids learn to build their own robot and to program it. And we run it at a Bedok Reservoir where it managed to capture some very nice footage of the turtles. And for those of you who rather stay at home, we do virtual robotics session also, okay, over Zoom. Okay, using simulators like the one that you see here, this Gears board. And we do coding programs such as Scratch as well as Python games. Next, please. Okay, so first, what is the Internet of Things? Next slide. Now, IoT, or the Internet of Things, is something that connects our devices to the internet, and that makes it a lot more useful. The one on the left, now that is the Philips Hue light bulbs. Okay, some of you may already have this in your home. It basically connects the light bulb to the internet and lets you control it using your phone. You can change the color of your light, turn it on and off, set schedule for it to turn off automatically or turn on automatically. The one in the middle is from Daikin. I'm sure you've seen the advertisement very often. They let you control your aircon using your phone. So if you're on your way home on a very hot day, you can actually turn on your aircon first before you even reach home. And by the time you're home, your room is already nice and cool. And on the extreme right, there is an actual Internet of Things toaster. It lets you toast your bread when you're not at home. I'm not sure why anyone would want to do that, but it's there. Now, how does IoT works? Every IoT system will have three components, okay? It's the same for everyone. On the left, we have our IoT device. That can be our light bulb, our aircon, or toaster. So the device in there is going to sense the environment and it's going to control some equipment to turn things on and off, to increase or lower temperature, to change the color of a light. We have our internet server. The internet server receives information from the device as well as from the user, and it does some processing and it stores the data there. And the last one is our user device. Today, it's very common for us to use our phone as a device, but there's also some which uses the computer. And these user devices are used to control our IoT equipment. Okay, next one. In the industry, IoT is used in a variety of ways. We use it to notify our vendors when our vending machine is empty. So in the past, we used to have people come by every week and check if the vending machine is empty and top it up if it's required. Okay, but with IoT, we don't have to do that anymore. The IoT device will monitor if your Pepsi or your Mountain Dew is out, and it will tell you to come in and top it up. You don't have to come by so often. You only need to come by when it's required. To track water and power usage. Okay, in the past, we used to have people from SP services. They'll come by every house and they'll take recording of your power and water usage. It's still done in some places, but increasingly more common. A lot of our water and power meters are connected to the internet so that you can automatically track how much you have used. You may have also seen some of these garbage bin. Okay, not this exact model. We have a slightly different model in Singapore, which monitors how much garbage is in the bin, so that when it's full, it will inform the garbage collector to come down and collect it. Okay, they don't have to come down all the time, only when it's full. And that saves them a lot of work. And I also ensure that we don't have a full bin sitting around all the time and people can't throw their garbage anymore. Next one. Now, very interesting thing about IoT is that a lot of people think that it's difficult or it's very expensive to do on your own, but it's actually pretty cheap. You can get, for example, an LED strip. Now that one looks kind of short, but for $15, you can buy about a 5 meters long strip. Controllers for the Internet of Things cost probably about $10. To code the device is pretty short. Now there's only about 13 lines of code, and that's already enough for this device. And we can control and can use that to create a mood lighting for a room. Okay, just like the picture that you see on the bottom left. Right. And for today, we'll be introducing the ESP8266. We won't be using the actual device. We'll be using a simulator since this is a virtual platform. Now, all of those devices that you see there, those are all ESP8266, just a different model. Okay, but the most popular one is the one on the bottom left. And this is what we'll be using in our simulator. Next. The ESP8266 is a microcontroller. For those of you who have done a microbit or Arduino before, it is very similar. Okay, it's a device that's kind of like a small computer. You can program it, you can tell it to do things, and it can control external devices like lights, fan, and so on. Now, the special thing about this particular controller is that unlike the microbit and the Arduino, this one has a built-in Wi-Fi connection. So it has a tiny little Wi-Fi antenna. If you see that there's a squiggly line there, now there's a Wi-Fi antenna. It lets you connect to the device to your home router, right? And from there, it can connect to the internet server. We use the USB port to program it and to provide it with power. Okay, we won't be doing that today because it's a virtual program. And there's a lot of pins. There's the input and output pins at the bottom. We use it to sense the environment as well as to control devices. Next one. Now, these are all the pins for the device. If you were to do a live program, we'll be connecting this up, okay? But since this is a virtual one, we'll have a virtual simulator. Can I have the next one, please? And this is our virtual simulator. Right, there's a link right at the bottom. Can you see that? a9i.sg/IoT. So this simulates the ESP8266 with some connection to a LED switch, a door, and some plant watering device. Okay, although this is a simulator, if you do have a real device, you will connect it the exact same way as what you see it here. Okay, so this is not fake. This is a real wiring connection. If you do have the actual device, can wire it up just the same as what you see here, it will work. Okay, next slide, please.
Great. So just like Court said, we can't really have you connecting electronics today with us, unfortunately. If you do come to our center anytime after this workshop, just let us know when you're coming and we can provide you with the actual device. Today, we're going to simulate how this device works, and we'll be walking you through all the steps necessary to get this working as if you were doing it in real life. The code will be slightly different. Obviously, we're not going to be using physical elements, but everything else, all the concepts are going to be applicable to doing this in the real world. So there are a lot of challenges in our virtual IoT home. We're going to be trying today to get some of them done, but I don't think we'll have time to do all of them. So one of the things we're going to try to do is to turn on this light. You could think of it as maybe one of your ceiling lights at home, or it might be a reading light, or it might be some light that's out of the way, a garage light, a light outside the door that you don't want to necessarily go out of the house to turn on. If you want to install a new light in your home and be able to control it from remotely by phone, whether you're sitting on the couch and you don't want to move, or whether you're away and you want to turn on the light for other people in the house, maybe wake up a lazy parent out of their bed on Saturday morning, you want to turn on the light from outside, you can do that. Another thing you might want to do when automating your home is if somebody rings the bell and you're not home, you want to be able to know that they were there. So this doorbell allows you to have access to basically getting a message over ding dong or music on your phone instead of the little ringer in your home. So when you can connect up a doorbell that will alert you on your phone when you're not around. We also have a remote control door lock so that maybe if somebody forgot the key, they ring the doorbell, maybe you give them a call, or you know that it's them and they forgot their key again, you can unlock the door for them. So this could be a remote control door lock that you can lock and unlock from your phone. And finally, we have our plant watering system. Maybe you want to be able to see how healthy your garden is. You should be able to create some kind of a plant watering system where first you can monitor the soil moisture and how happy the plant is. And second, you can plug in a small water pump with a water source and be able to turn that water pump on or off whenever you think the plant either needs water or has too much of it. And you can see all of this stuff on this website, which I'm now going to go to. So we're going to start doing some work, and I'm going to switch away from slides, and I'm going to start sharing basically the website that I just shared with you, a9i.sg/IoT. And I will also share an emulation of my phone. It's not really my phone, but I'm going to show you on screen something that looks like my phone. Okay, so let me show you what that's going to look like first. Just give me a second to set it all up on my screen. And there. So on the left side, we see the IoT simulator, the home automation simulator that Court created for us for today. We have the actual board. It's just a picture of it, but it's all the pins are correct. They're connected to a bunch of electrical elements, like we said before. You can interact with the screen, unlike the other one. You can, click the bell, and you should be able to also interact with this coding area down below. So we're going to get started on that in a second, but before we do that, I want to make sure everyone has Blink on either their phone or their tablet mobile devices. If you don't have Blink already by now, you can take the time while I'm discussing how to set it up, the first project, to do that. You'll have to catch up later on. Two things about that. Number one is we have all the slides with very detailed step-by-step on how to do everything I'm going to show you now live. And second, if you are very close to finishing, or if you missed one point during the slide today and you want to talk to us about it, you can stay a little bit later today. We'll be on the Zoom call almost until 12:30, maybe even later. So we'll give you an extra 30 minutes at the end if you have some questions and you want to go over any particular details from this and try to get at least one of these projects to work. So we'll start by just connecting our device to connect our IoT device to our phone first. So that's our first step. The phone is going to have, a remote control button, let's say, to turn on the light, and the light is already connected to our device, and we're going to need to put some code in to make sure that we receive those triggers whenever the person is clicking on their phone. So in order to do that, we need Blink on our phone or on our iPad, tablet, and we will have needed to already register it because we will need some email in shortly. Let me start. So this would be the welcome screen once you get into Blink. We're going to start by creating a new project. And our project will basically be a new dashboard that we're using to create the home automation device. So I've clicked the new project now. I'm going to give it a name. Let's call it home automation. You can call it anything you want. Make sure to choose the device properly. Normally we would use ESP8266, but today, because we're using a virtual environment, we're going to be using the generic board instead. Okay, so again, your phone should look similar to this if you already have Blink on it or your tablet. Next, your connection type. Normally you would choose Wi-Fi and you would be connecting to some router. Today we're going to be using just, again, a generic device for this, a generic connection type. We're going to be using what's called the Ethernet connection type. Okay, so we have the generic board as our device. We have Ethernet as our connection type. You can choose a theme of a dark or light, up to you. For the sake of this tutorial, I'm going to be using the dark theme because it shows up better on my screen and your screen. If you have a question up until this now, from what I just showed from this screen, you can either type it in the chat. I can see Angeline, for instance, has asked a question on the chat. One of us, either me or Court, will try to answer our best in the chat itself. But if you have a very persistent question and you see that we are not answering, please feel free to unmute and let us know as well. So if you don't have Blink yet, now is the time to get it. I'm going to be continuing, but again, all of the slides are available and you can catch up either now throughout this hour or in the next few, just after this hour, and also at home offline, because the slides are super detailed and you should be able to follow them step by step. So I'm just going to be going through just because we're limited in time. And I want to try to get at least two of these 4 things that we can do going. Okay. Right, Court will be answering questions on the chat. I will be continuing. So again, I just gave it a name. I called it home automation. You can call it whatever you want. I chose the device generic board. and I clicked on the Ethernet connection type. Okay, and I've now created a new device. Now, this is a very important step. If you've registered Blink correctly to an email, your email will now have a new message from Blink. Mine was sent to yoni@posteriori.com.sg. That's my email. Yours would have been sent to you. And you're going to need to open that email and copy and paste that authorization link. Now, wherever you have this screen open, the Internet of Things simulator, that's where you're going to need to copy and paste that token to. So if you have this Internet of Things simulator on your laptop, your Blink would be on another device. You would have gotten to this step. You would have received an email. Now you need to get that email on your laptop, let's say, if that's where you have this simulator going. And you're going to need to copy and paste a very long set of characters. I'll show you maybe what it looks like in a second. From the email and into a coding block here that we're going to show in a second. But I just wanted to, again, reiterate that you now have, if you've created a new project, a new home automation dashboard project, you will have gotten this little window and you should be receiving an email in your inbox with a long character string, and you need to copy and paste that into this window. And I'll show you how to copy and paste it now. Okay, this is what your dashboard starts out with. For me, because I already have this emulator on the screen, instead of going to my email, I can either email the token to myself again, or I can just copy it now and put it directly into my code. You are going to probably need your email, unless you have both this Internet of Things simulator and Blink on the same device. Okay, once you've gotten that email, now let's figure out what to do with it. First, I'm going to click on the Blink tab underneath. For those of you who've done coding with Scratch or any of the other block programming type of coding environments, Tinker, Scratch, there's so many. We've created one called GearsBot recently. Blockly is another one. There's quite a few different versions of block programming environments. We're using Blockly, which is an open source environment that you can reuse in your own simulators and in your own coding environments. And so some of these blocks you will have never seen because we've invented them just for today. So we're going to use first the Blink tab, where we're going to have a lot of blocks that have to do with manipulating things either from the Blink mobile device or from the IoT device here, this ESP8266 that we're connecting to. So normally this code will be written in C or C++ for an Arduino device and downloaded into an ESP8266. Today, we're just using a block programming version of it. There might be some environments that already allow you to do this, for instance, mblock, but we've created our own version of it just so that we have everything on screen at the same place. Okay, so I'm going to pull out a when started. It's the first block under the Blink tab. I'm going to pull it out into my programming area. Everything I put here is a code that I'm going to be running whenever I click the run button on the left side here. Okay, and when I start, I basically the main thing I want to do is I want to connect to my IoT server. I want to connect to Blink. Okay, so I'm going to do that with this. And this is the block, and I had to scroll down. So it's in the Blink tab, and I have to scroll all the way down. It's the one before the last, I think. And it looks blue-ish, and I'm going to drag it out and stick it into a when started block. Okay, this will tell my ESP8266, my virtual ESP8266 here, to connect to my phone. the blink that's running on my phone. Okay, and now is when I need that long string that you should have received in your email. And mine looks like this, and yours would look slightly different. Each one of us will have a different string. Don't try to copy the string on my screen because it's not going to do anything useful. I'm going to pause here for a couple of seconds. I want to allow people to get a chance to first get Blink on their mobile devices. Second, to have created this first empty dashboard, the first project. So you would have clicked new project on the screen before. And I want to let you have the opportunity to get that email with your long string, and to be able to add these 2 bits of code blocks and copy and paste that string. If any of you have gotten to the point where you have these 2 blocks and your authorization token string copied and pasted into the block, you can either unmute and let me know, or you can tell us in the chat. If you've done that already, it would be great to know so that I just have a sense if anyone is able to follow. I'm just going to try to pause here until at least 1 or 2 of you have managed to do that. So you would have had Blink. You would have had Blink. You would have been able to in this window that you would have first gotten, you would have been able to click New Project. You would have chosen a project name. You would have entered generic board as your device, and you would have entered the Ethernet connection type. You would have chosen a theme. Again, put a project name, whatever you want. Oops. Something like this, and you could click Create. Once you do that, you would get an email with an authorization token. Okay, so Angeline, the next step, you have the token. You need to start this IoT of Things, Internet of Things simulator. And in that simulator, you need to be able to add these 2 blocks of code. Yes, if you had a problem with your project, you can click on this nut-looking image. Click on that, and you should be able to go to your device, and you should be able to select different whatever hardware model and connection type you need. So let me show that again. If you've made a mistake up to this far, like Angelina is saying that they forgot a step, you can click on this nut picture icon right next to your project name on the top, and go down to where it says devices. Click on the device that you chose. Click again on the device that you chose, and select the correct hardware model, which is generic board and connection type Ethernet. From there, you can also ask Blink to email you again that authorization token. Which is the IoT block. So we have 2 blocks so far on the screen, a when started block and a connect to IoT server block. They're both inside the Blink tab on the top left of our coding programming area. Natalie, congratulations. You're our first finisher of this. Natalie, if you can now try to run your code and see if anything changes on your Blink screen. Good job, Sparsh. Laurel, well done. So you guys can try to run your code and see if anything changes on your mobile device. You didn't see the nut. You might need to if your image looks like this, then you need to click once with your finger on the home automation device. If you see these two dots on the bottom, you might need to click once on the home automation device so that it selects that, or whatever name you gave to your project. You can just click on this area with your fingers and it should change and start to look like this. So if your picture looks more like that, that means that you haven't really gotten into your project yet, and you need to select it first to be in your project. Then it would look like that. If you don't have any project at all, if your screen looks like this, then you need to click on New Project. Oops, don't want to log out. Okay. So I'm back in Home Automation. If I haven't run my code yet, or if I did some mistake, I would see this, when I click Run, this play button on my Blink application, I would see this one warning on this image. And if I clicked on that, it would show me that, oh, your device has never been online yet. Okay, but if I have my when started block and my connect to IoT server block inside, and I've copied the correct device authorization token, I can now click Run on my simulator. And now I see that warning sign went away. It went away, but also it hasn't said that it's online yet. Let's wait a second. I would have expected this to have changed. Maybe in your case, it will have changed to say last seen online or currently online since some time. Okay. Maybe as we go along and I add some more details there to what I want my device to do, it might change what it says, but at least I can see that the little warning flag has left. So that's what you want to see when you press play on your project on Blink, as well as press run on your simulator. If ever you want to press run again and it's not allowing you to because it's grayed out, you can either move some code around just to refresh it. You can also refresh the screen by pressing F5 or however you refresh your web browsers. Okay, I'm going to now click stop so that I can go back to my home automation device. Sorry, my home automation dashboard, the application that I'm trying to build on Blink. And I'm going to now add a button. Okay, we're ready to now add a button, and our button will try to turn on the light, the LED light. Okay. In order to turn on the LED light, eventually I'm going to need to tell my board to turn on this pin, which says D0 next to it. But before I can even do that, before I can turn on D0, maybe I can just show you that quickly. If I do turn on D0, make this bigger. If I do turn on D0, I think it's, yeah, it's the last piece of code. The last block under the Blink tab is turn D0 on. If I add that to when started and I just click run, I'm both going to be connecting to Blink as well as making my LED turn on. Just to show you that all we need to do is get this pin turned on in order to get our LED light on. I can do that with just, just doing it by adding this code whenever we start, whenever we click run. I can also turn it off by selecting the off state and click run again, and it will turn it off. But that's no fun. We're not trying to just code the ability to turn things on and off with our device. We want our phone to tell us whenever we want to turn things on and off. Okay, so I'm going to show you how to do that. First, we're going to need to create a button on our device. If you don't see these three icons on the top, it might mean that you need to click the off button, this stop button, so that your Blink application or project is stopping. And now I can press the plus sign or click anywhere on the screen, and it will give me this widget box and allow me to add a button. So don't worry about this, what looks like dollar amounts. They're just your how much can you add to your Blink area before you need to maybe pay some money to Blink to use it for more. Everything we need to do in this simulator is can be done for free. So no worries about clicking on these things. Whenever you run out of electric symbol money from Blink, you can always delete one of your buttons and add another one. So Blink is free up to a point. All right, so I clicked the button. First I clicked plus. I got this widget box, and then I clicked the button, and it placed a button on my screen. Now I can click on that button and change some of the settings. Normally, we might choose one of our pins directly from the ESP8266 to do this, but since we're virtualizing a bunch of this, I'm going to select a virtual pin, and I'm going to select V0. Okay, so when we're selecting pins for inputs from Blink, because Blink is not connected directly to my ESP8266, my microcontroller here, I need to basically tell it to do something. And instead of telling it, oh, somebody clicked the bell that was connected to D1 or somebody did something on these pins, I'm telling it virtually somebody actually maybe pressed something that looked like a pin, maybe a button connected to a pin, but it was done virtually from somewhere else. In this case, from the Blink application. Okay, so once I've selected virtual and V0 on my pin, I'm ready to go pretty much. I can also change the name of this button. I'm going to be using it to turn on a light, so I can change the title of the button to light. Okay, I can also change the labels on the button. We can also change the button from being a push button to a toggle switch. When it's a push button, I just push it once, and it will send a signal, but then it becomes off again. It turns off again. Let's see how that works first. Okay, so we have now a light button, light switch, with V0 as the pin. And now I can go inside my Blink tab again, select when V0 receives data, and for now I'll just turn the light on directly. Later on I'll just add a little bit of code, but for now I'm just going to just turn on the light whenever I see anything from Blink. So now I'm going to run the Blink application. I'm going to click run on the side here, and I'm going to click my button and see if my light already turned on. Let me do that again. I will add some text first. So I'm going down to my text tab, and I'm going to print some text. And what I'm going to print is whatever I've received from Blink on this tab. And I'm going to click run, and it's going to show me here what I've received. And it tells me I've already received a value. I forgot about that. Whenever we start, we already received the state of the button. So I can't just turn the light on just whenever I receive any data. I have to wait till I receive a particular data. So if I bring back my Blink device and click on it, you can see that while I'm clicking on it, I'm receiving a 1 over here. And whenever I let go, I receive a 0. So I'm already seeing some connection between my Blink device, which is on my phone or my tablet, and my IoT device, which we're virtualizing in this simulator. Okay, now we need to do something with that information. So again, if you've done some coding, this will be easy for you. If you haven't done any coding, this might be a little bit challenging. You can follow it from the slides later on at a slower pace. But I'm just going to push ahead here so that we can get some of this to happen before the end of the session, which is coming soon. Okay, so I'm going to add an if block. To my if block, I'm going to add an else. So now I have an if else. And I'm going to ask the question, what is my received data? I'm going to add this comparison from logic. I'm going to add a received data on one side. I'm going to go to math and add a number. So I'm going to do that one more time. But this is, for those of you who know how to code, you should be able to get this picture going. If I receive 0, I want to turn my D0 pin, which is connected to light, off. And if I receive 1, any other number than 0, basically, I'll turn it on. And if I run this code, I can see my light has turned off up here. Bring this code on the screen. Okay, so you can try to get this code written if you know how to pull blocks off and on. If you've done some programming, this might be easy for you. For those of you who haven't, again, you can try to copy from this. But basically now I can see that whenever I click my device button, the light button, I'm turning on my LED as well. Okay, and whenever I let go, it turns off. And if I wanted it to act more like a switch, I can click back on my button and turn it to a switch. Now whenever I run my Blink dashboard, I can keep the light on forever, and I can see that it's on, and also I can turn it off. On, off. There we go. This is the first challenge. We will try to do one more thing, but I think I'll pause here and wait for some questions and maybe show you again how I added this bit of code. Okay, first I just added a print receive data. The print came from the text tab. It's the third block there. I just added that. And then I went back to my Blink tab and I found received data. And I just used that to show the state of V0, which is the button on my Blink device. Okay, whenever I run my simulator now, I can see if it's on or off by just looking at the data. And then what I did was I went to logic, I added an if statement. Once I have the if statement, I can click on this gear. I can add an else underneath to just build up some more information, some more conditions. So I have two conditions. If something happens, do something, else, do something else. So, and then from there, I went to logic again, and I pulled down this comparison. And I could use duplicate data, duplicate block by right-clicking on the received data block and clicking duplicate. You can also go back to the Blink menu to get it, but I need another received data block here. And I want to compare it to some number. So I'm going to math, and I'm going to pull this number block. So now I've compared it to 0. So if received data is 0, I want to turn off D0, the D0 pin, which is down at the very bottom of the Blink tab. I'm going to bring that turn D0 block, and I'm going to change the state to off, because whenever whenever the state is 0 on my button in Blink, I want to turn my light off. My light is connected to the D0 pin here. And whenever I get anything other than the 0 value, I want to turn my light on. So I get another one of these turn D0 blocks, and I change the state to on. And this is all we need. This is all the code we need. to connect the device. I need to run this again. To connect our blink device to our simulator. Sparsh, fantastic. So at least some of you are able to follow along and be able to complete this far. If you've done this much, you can also try to connect your pump and connect your door. They're just connected to different pins. So for the door, we need to turn on and off D3. For the pump, we need to turn it on and off D2. And we'll need to create different buttons for each one of those. So I'm going to do just the plant very quickly now. I'm just going to add another button. If you haven't been able to figure it out, that's okay. I'm just going to do a few more things for the next 10 minutes. We will be sticking around for another 30 minutes to help those of you who are really interested in getting it. I'm going to create another button now. So what I did was I clicked on the plus button again. I went to my widget box and clicked on button, and it added a second button for me. I'm going to call this button the pump, because this one, or water, this one is going to be watering my plant. And again, I'm going to change my pin to a virtual pin. This time I'll use V1. Okay, and I'll make this one a push button, so I don't want to swamp water on my plant by mistake. So I'm just going to make it a push button, and I don't need to change anything else. Leave that there. Now I have a V1 button. I can just duplicate this entire bit of code that I have, this entire when V0 receives data, by right-clicking on the outer layer, on the when receives data block. And this will create a second when receives data. I'm going to minimize my screen a bit because now I'm starting to have too much code. And I'm going to change when V0 to when V1. So this one is controlling the new button, is being controlled by the new button. Now, if I didn't change anything else and I run it, both of them are still changing D0. So no matter whether I'm connected to, doesn't look like V1 is working yet. Try that again. Okay, so now my water is controlling the LED as well, which is not what I want to do. So how do I change that? Well, I have to change what I'm turning on whenever this virtual button pin is being receiving data. So when V1 receives data, I don't want to turn on D0, which is connected to the light. I want to turn on my pump, which is connected to D2. So I'm going to just change my digital pin from D0 to D2, and I'm going to turn that one on now and off. And I can see my plant is wilted here. I'm going to run my code again. My plant wilted because I haven't been watering it. So now if I turn my water on, I can see that the shower starts to flow, and I can see maybe that my plant will come back alive. Now, if your plant dies in real life, you know, if you water it, it won't necessarily come back to life. But we're just trying to simulate what happens, you know, whenever we are sprucing some water into our very thirsty plant. Okay. All right, so as soon as I stop watering it, I can see my plant dying again. So I'm going to just have to keep watering this. You know, my daughter really is engaged in this part. She cannot stop watering. She's really upset whenever the plant starts to wilt. I hope you're not, and that you can let go of the plant and not keep this button on forever. If you do want to keep this button on forever, you can turn it into a switch. Okay, the next thing I wanted to try to do is I want to try to add one bit of intelligence, which is something we haven't seen yet, which is read some information from this device and show it on my screen. We can do that by either receiving whenever the door bell is ringing, or we can see the soil moisture level of the plant. Let me do that because it's just slightly more interesting and more visually appealing. So I'm going to look at the soil moisture. The soil moisture device is connected to our D3 pin. So I'm going to need to, sorry, the soil moisture device is connected with the pink line all the way to our analog 0 pin on the top left here. So we're going to somehow have to read from this A0 pin and into our blink device. And there's a very simple way to do that. I'm first going to shut off my blink application. I'm going to add a new widget. And that widget is going to be, I'm scrolling down until I see gauge. There might be some other widgets that you can use, but gauge is a nice way to look at some analog measurement. An analog measurement is any, a large range of numbers, not just 0 or 1, not just on and off, but a range of numbers from, in this case, it's going to be from 0 to 1023, just because of the nature of the device that we're using. Okay, so I'm going to click on gauge, and it's going to show me this, what looks like a speedometer maybe. I'm going to grab onto it, you have to push your finger on it, hold it for a while, it will change to look a little bit bloated, and then you can move it around. I'm just going to put it just slightly below here. I'm going to put my water button right over it. So this is my watering area, and this is my light area, they're separate. And now I'm going to click on this new gauge display, and it's going to show me the settings. I'm going to call this moisture. You can call it anything you want. You could leave it blank for now. And I'm going to change my pin. Because it's connected from this pink area to A0, I'm going to change my pin to, again, to keep it on analog, actually, in this case, and move it to A0. In this case, there we go, analog A0. In this case, we don't need to virtualize anything because A0 is really the pin that's receiving information from the soil moisture device. In the other cases, our pins were virtual because V0 and V1 are really things that are happening on the blink device, not directly here. The other real pins, D0 and D2 that we're using, they're only to turn things on. So we're using them for real only on our device, but we're using a virtual input pin from blink. In this case, we don't need a virtual input pin because the input is coming from A0 directly. So we can use analog A0. And once I do that and go back to my application and press go, I can see my moisture level currently is at 0 because I've let my plant wilt. But if I start turning on my pump and leave it on, I can see that the moisture level starts to rise. Okay, and if I keep my pump on, I can see the moisture level keep on rising and rising and rising. And as soon as I let go of it, the moisture level starts to go to reduce. Okay, so this is a cool thing. You can look at your phone if your plant is starting to have problems. You can't see your plant, but you can see the moisture level. You might want to give it some water and say, oh, 600 is too low. I want to keep it above 700. So I'm just going to give it some water. Oh, the water level is already at 800. I'm going to stop. Right? So you can do that. You can also automate your plant so that whenever the device sees that it's under 700, it gives it more. I'm not going to cover that, but it's covered in the slides. Okay, for today, this is all I really want to cover because I think a lot of you maybe are having some problems connecting. If your buttons are not doing anything, make sure that whenever you've coded your, added new code to your simulator, you've clicked run here on the simulator itself. There's a run button. There are two run buttons, one on the simulator and one on your Blink dashboard display. So you need both of them to be on. One of you is unmuted. Do you have a question?
进的可能是有
Callista and Kinney, I can hear you. If you have a question, please ask it. Otherwise, you can mute yourself. Okay, so with just these 3 blocks of code and all the other things that are inside them. I've managed to already turn on my light. I've managed to already read from my plant. And I've managed to already turn on my pump. And the plant reading is not even in here at all. The only thing that I needed to do for plant reading is to connect my IoT device to the IoT server. Once I did that, the only thing to get this moisture gauge to work is to just create the correct setting that it's going to read from A0 on my device. So it connects to ESP8266 somewhere far away. It reads from its A0, the current state, and it logs it back on your screen. Now is a good time to take a bunch of questions, and we'll wait until maybe another 3 or 4 minutes to see if you guys can connect these two things. So I have a question about the authorization code. If you need this authorization code, you need to be able to first create the project here. Once you've created this project, you need to send yourself an email, or Blink will have sent you an email. So you need to go to that email. You need to go to the email which you use to register your Blink app. And that email is going to be from Blink itself. And it's going to say, hey, you've just created a new project, and here is your authorization token code. And it's going to look like something like this. And you're going to need to copy and paste that. So wherever you have this IoT simulation running, it would be the easiest if you have also your email as well open. And again, if you go to our slides, we have all of this information in our slides. We'll be here for another 30 minutes to help you after I conclude. But if you don't even have time to finish it today in the next 30 minutes between 12 and 12:30, you can always go back to our slides, which I will add again to the chat maybe. And you can just follow along with the slides. The slides will have all the little things that I did throughout the day today. They're all there in about 50 different slides. There are 50 different step-by-step slides to show you exactly how to build what I've shown you today. Actually, and more. It will also show you how to use the doorbell. It will also show you how to unlock the door. And it will also show you how to create a self-watering plant system, more automated.
Hello, I have a question.
Please, yes.
Yeah, so this is the virtual one. If in real life, like can you just roughly tell us what would the difference be if we tried to build something like the light, the LED one? Like how would that look like versus what we're doing now?
It literally would look like this. Your ESP8266 device would look like this. You would have wires connecting from D0 to the long leg of the LED and back from the short leg of the LED all the way to ground. And you'd be able to turn on this little tiny LED. Now, if you wanted to power up something that requires more power than just 3 to 5 volts, then you would need to have some other electrical components in there, maybe a transistor as well as a new power supply, something to light up, for instance, a ceiling light or an LED strip. It might require more power than what can be delivered directly from this board. But otherwise, if we were just to go into a lab or do this workshop in real life, we would give you an LED that looks very much like this. And you would be using wires to connect them directly to these ports on your ESP8266. So at your home, it might look different, but in the lab, it would look exactly like this. So we're really simulating very, very closely what the lab workshop would look like. Of course, you can imagine that instead of a small, tiny LED, you would have a big, a big LED strip like Court showed earlier today, or a normal LED ceiling light, or even a regular ceiling light, fluorescent or incandescent, being powered just slightly differently than this, but it would look pretty much the same. you would still need to get some wire from D0 or from one of these pins to tell your electrical component that it should be either on or off. Noah, does that answer the question?
Yes,
Thank you.
Great. And again, if you were to come to our center in the next few weeks, just let us know if you're coming. We can provide you a kit that has all these little tiny elements that, or some of these tiny elements, electrical elements, so that you can do it in real life if you enjoyed this. Okay, I think I have to stop sharing here for a second and share some of our concluding slides. I think our IMDA partners would like to leave at this point. Me and Court are going to stay for a little while longer, but I'm going to let the IMDA personnel just say their last few things. Just a second as I just give you a summary that if you want to learn more, again, there's so many other ways IoT devices can work. And again, all of this is in the slides. There are a lot of other components that we could connect to. We can run motors that control robots. We can run other kinds of sensors that tell us other things that are happening, tripwires, or some way to detect, like an infrared sensor to detect if people are moving around some place. There's so many things you can do with IoT and with these electrical components. And again, you can learn more from us by visiting us. All the information in here can be found on the slides that I provided you the link to, and you can visit us at our website as well. And you can contact us at any time. Our contact details are in the website as well. Okay, AMC and IMDA, thank you for partnering with us. I'm going to hand them over for a few minutes to tell you a little bit about how you can review our workshop. I thank everyone for coming. If you would like to stay, please stay. We will be here for another 30 minutes.
Hi, everybody. Thank you for joining us today. This workshop is conducted in support of the Smart Nation Together series. Visit the website or scan the QR code to find out more about the programs available. We'll also appreciate if you could take a couple of minutes to complete a survey on the workshop and stand a chance to win $5 food vendor vouchers. Please use the QR code or the link provided to complete the survey. Winners will be notified by email.
Okay, I'm going to leave this QR code on for a couple of seconds. If you would like a chance to win this voucher, or if you just like to leave us either thank you, or you did a great job, or hey, this was crazy and too fast-paced, and try to do something different next time, please let us know. We would appreciate any and all feedback.
Thank you. For more exciting tech experience offered by SG Digital Wonderland, click the link provided to find out more.
Again, you can't click on this, but you can type this into your web browser, or you can use the same QR code. I think also SGDW2 has provided us with some of these links as well. Oops. Okay, for those of you who want to stick around and ask questions, the floor is open. We will be here for the next 30 minutes to help you get any of these things that I showed you to work. So feel free to stick around. If you've had a nice session and you're done, or if you wish to do it sometime on your own time, feel free to leave us now. It was great meeting you. Thank you from Court and I. We really appreciate your interest. So feel free to unmute if you have questions, or send us in the chat if you'd like us to help you do anything. And thank you again, IMDA and AMC. If you're done, feel free to leave. I will keep this Zoom room open for another 25 minutes.
Hi, Yoni. Can you tell us more about your physical workshops? And also, like, if you wanted to buy these boards and stuff like that, can you tell us a bit more of that?
Yeah, I'm going to let Court answer that question.
All right, you want to know about workshop, right? For this holiday camp, we have been running 2 workshops. We just finished one of them, the underwater robotics, so a bit too late for that. We have another one coming up on, which week is that? 7? The week of 7 December. Okay, that's on microbits in space. So it will be a workshop that covers coding, some electronics, and science. Okay, you can find out more from our website. Right, and your second question is about buying the parts, right? Okay, if you're in Singapore, you can just drop by our center. We'll be happy to give you the parts that you need. Okay, and the reason we ask you to come down is so that we can show you how to do the wirings as well. Okay, it's quite hard for us to show you the wiring online. If you want to buy the parts, I'll be putting up links on the website on where you can order the parts. Okay, any other questions? Angeline is asking about online classes. For online classes, currently we have online class on, is it Wednesday, Yoni? Right, we have a virtual robotics and coding program, right, as well as a Python game programming. Okay, we're not doing electronics online though. For microbit in space, that is on the week of 7 December. Yes, Angeline, no electronics online. Unfortunately, if we were to do it virtually, it's really, really hard to help with the wirings. We tried it before, it did not work out very well. Angeline, yes, sure. I think Yoni should be putting in the URL for you to register if you're interested. Kalista and Kinney, besides the 7 to 11 December, I have had requests to run a second run of the underwater robotics on 14, on the week of 14 December. So if you're interested in underwater robotics, drop us an email. If we have enough interest, we'll start a second run of underwater robotics on 14 December.
Somebody asked about being able to do electronics online. As Court mentioned, it's quite challenging. If you do have an interest in it, specifically in electronics and being able to wire things, and you are willing to do it completely virtually, there is we can just tell you that you can go on to Tinkercad. They have Tinkercad has a cool circuits, virtual circuits application that you can use from home. If you need help with it, we can start a class maybe on how to use it, but I believe they have a bunch of cool tutorials on how to do that. They don't cover IoT, but they do cover a lot of other things. And this is how you get to Tinkercad. Tinker Academy is both one of our partners and competitors. You can find out more information about them by going to their website. Tinkercad is not a competitor. Tinkercad is it's an Autodesk website and application, a web application that allows you to do 3D designs as well as virtual circuits using Arduino. So I can show you maybe quickly a little bit of what I'm talking about. So this is the tinkercad.com website. Has nothing to do with Tinker Academy. It's Autodesk. Autodesk makes professional industry applications for engineers and architects to use, but it also provided this cool educational software for free, and you can use it to, first you can create a bunch of 3D designs, but if you go to their circuits pages, you can create Arduino-based circuits. You used to be able to use ESP8266, but due to various challenges, security issues, and technical limitations, they've stopped allowing to do that. So no IoT, but you can do everything else. You can connect LED strips. You can program as if you had an Arduino with electronics. Again, this can be taught online. We don't offer it right now, but if there's a huge interest for specifically this, we can consider doing something like this. So you connect your wires, you bring LEDs into your area, you connect your wires, you write code for your Arduino. It has both text and block-based, so you can do both. And you can start a simulation. And I think in this case, the further away, maybe the more LEDs will light up, something like this. Can't remember. Yeah. So here's a device that an electronic device that you can wire up virtually and also code virtually using something like the microcontroller that we just used, but without IoT. And it can be reactive, and you can simulate some physical things that are happening with it, similar to what we just showed with IoT. So I recommend you guys use this if you're really interested, and if you have trouble doing this on your own, you feel free to contact us, and we can provide more information and possibly run other workshops or courses on this. We run our center. Most of our programs that we run are actually with the Ministry of Education schools in Singapore. We run robotics CCAs, ALP programs for secondary schools, even some CCAs for junior colleges and tertiary schools. So if you are interested in coming to our center, it's really a side project for us. Please let us know before you arrive there. Everything is by appointment. If you're interested in our virtual coding, you can just send us a note. I've sent some links in the chat already about how to get in touch with us, both about the camps, also about the coding classes, and also Court just provided with our just general email, anything you have any question about.
Hi, can
Yes.
I ask a question?
Yes, please, go ahead.
On the doorbell in the simulator, I see when D1 is pressed, but is it possible to say D1 is pressed and then make a sound or something, or what can we do with D1?
You want to know about the doorbell?
Yes.
Do you have the slides already? Did you get the slides from the link?
Oh, is it the slides? Okay.
Yeah, the slides cover all the other things you can do. The doorbell, which I haven't covered, as well as the door itself, the door lock, as well as how to automate the watering plant system so that you don't have to watch it and water it yourself. All of that is available in the slides. It's at A9i. I'll just type it down here. SGDW slides. I think that's a PDF file, and specifically what you were asking me about, which is the doorbell, would be on slide. It's challenge 4, and it starts on slide 45. No, the slides would look something like this, slide 45. And for the doorbell alert, you add a notification to your application. So if you can't find our slides, this is what the first slide would look like for that. You need to tap plus to open the widget box. The widget box opens. You scroll down and add notification. After you added the notification, we see that the doorbell is connected to D1, so we have to read from D1. So we can add this code whenever D1 is pressed, sends a message. And once you send any message that you want, it would appear. If you added notification to your Blink device, it would add that notification. Yeah, I still see that there's about 8 of you with us. If you have any other questions, let us know. We'll keep this on for another 14 minutes or so.
Sorry, one last question. What are your opening hours? You mentioned we could go down to get the parts. Like, is it what are your normal office hours?
Yeah, as I mentioned, most of our work is actually done at public schools here in Singapore. We do some retail work in our office, but we don't necessarily have people there all around the clock. So if you want to come and collect a free electronics kit to do IoT, just send us a note. Either go to the contact us link on our webpage, or we can add again our email. So just let us know ahead of time when you're coming. We will set up the time with you. Our email again is Court just published it. I think I forgot to mention, but yeah, if anybody is interested in this video recording, I believe we'll either be putting it on YouTube, and IMDA will tell you where to get it, or again, if
We'll put it on the website together with the slides.
okay, yeah, it will be just next to other resources, the same area where the IMDA slides were. All right, cool. Anyone else having issues trying still to automate anything else on our virtual simulator? Let us know. Or if you have any other questions. Evan is having an issue with the authorization code. Evan, if you'd like to share with us what you're doing on your screen, I will stop sharing mine. And you can even share with us your simulator, and maybe you can share with us the email that you got, and we can advise you on how to continue. Bye, Laurel. Nice meeting you. Thanks for joining. Evan, do you want to try to share your screen, your laptop, wherever you're doing the IoT simulator? We can try to help you if we see what you're doing. It's hard to answer these questions without. Oh, sorry, you're right. My fault. Let me allow it. I will allow it at this point. Okay, you are now allowed to share screen. Okay, let us see your IoT simulator first. It's the third tab, I think. Go to your, okay, so this is the email you got. Where's the authorization code? This isn't it yet, right? You need to get a second email. Are you saying you never got the email with the authorization code? Either unmute or chat the answer. Evan, if you never got an email that has an, okay, let me show you again how to do that. I think you never created your, so I'm going to share over you now, if that's okay. Okay, so, oops. So here's my my Blink, right? You should have something that looks like this because you got that original email. You should be, if you haven't created a project and received another email, you should be in a screen that looks like this. In order to receive the authorization code, you actually have to create a new project first. So create a new project, type in a name, choose the device to be the generic board, choose the connection type to be Ethernet, and click Create. The name could be anything. So once you've created this, then it will send you a message that says, hey, your authorization code for this new project is so-and-so. If you do not get that authorization code message, then I'm not sure how to help you because that has to do with you setting up the email correctly on Blink and maybe allowing Blink to send you emails. It looks like you're already receiving emails from Blink, so it should work. Once you click Create, you should be able to receive a new message, and that message will contain what you need. So far when you showed me the email, I didn't really see the message that you need yet. When you click Create, you would see this window that says authorization token was sent to. Make sure it's the correct email. You saw the dialog box and it said your email, but you never saw the email in your email. You might want to check your spam, your spam folder in the email. Again, I can't really help because I don't want to I don't want to have access to your email. So you must be able to find the email that says the authorization code. Great. I hope that helped you. We have both our old IoT program and the new IoT program in the same website area. I'll share the, which was in the slides. It's under other resources or curricula in our website. If you go to the link that I'm providing in the chat, you should be able to see information from the slides from today, which will be the first link. And there was also a link to another page that has all of the slides from last year, which include how to code an actual ESP8266 in real life with Arduino. Those slides are also very, very, very detailed, and you could follow them step by step to create what we created today in real life. Great, Angeline. I'm happy you enjoyed it. We enjoyed your participation. Thank you for being so attentive. Okay, another 5 minutes here. If you have the last question. We have Natalie, who was our first to be able to connect her device to Blink. And we have Evan and Angeline. Angeline, it was meant to be a bit challenging. That's why we provide all this offline information. You can now take a breath and spend an entire day trying to sort it out. And again, if you can't, just let us know and we'll try to help you. As you can see, it was challenging for me too, as I was doing it. Okay, another 3 minutes, and then I'm going to close the Zoom room. So if you have any last question, feel free. Yes, please. And again, you have our all of our details. You could always go to our website and send us an email if you're missing some information. Don't worry, you don't have to leave. It's at some point I will just leave you out. Maybe you let me know when you're done copying the chat. It's just all too bright now, so I'm gonna have to put my shades back on. Natalie, Evan, if you have nothing else, feel free to leave the Zoom, rest your eyes, get a drink, toilet break before your next Zoom activity. I'm very happy. Evan, you have our information a posteriori. If you have a question after this, after I leave this and close the room, feel free to contact us. We're very happy to work with interested adults, students, kids, whoever wants to know something that we actually know. We'd love to share that information.
Thanks, Yoni. Thanks, Scott. I'll be leaving now. Going to get ready for the next activity.
No worries. Thank you very much for allowing us to participate. It was fun.
No, thanks for the great workshop. Thanks. I'll see you.
Bye.
Bye.